Hey guys, welcome to Homework Help for Year 8, Term 3, Week 4. On page 30 we have the topic review and we're going to go through the questions now. Question 1 to 4 just ask if you understand how to do the three types of transformation: translation, reflection and rotation. I'm going to skip those and go to question 5. Question 5 says, this shape is a rectangular prism. Name the congruent faces. The word congruent just means identical, so name the identical faces. So for example, the first shape is this one, the left side and the right side. These are congruent. So you can say left is congruent to the right. You can also say ADHE is congruent to BCGF. Okay, but you don't have to write this. It's kind of tedious. Just write this is fine. You can say top congruent to the bottom, and you can say front congruent to the back. That's fine. Question 6. ABCD is a rhombus. So let's draw this rhombus so we know what we're dealing with. Okay, let me fix up this rhombus. Okay. Now the rhombus has all the sides are equal. Now this will be A, B, C, D. And it says, is AC an axis of symmetry? So is this line AC an axis of symmetry? Well, we know the diagonals of a rhombus bisect the angles. Okay, so that means that this diagonal AC is going to cut this angle in half. So this will be, and this also cut this angle in half as well. And we know that the opposite angles of a rhombus are equal. So we know that these angles are equal. They've been cut in half, so they're all the same. So this angle, let's say this angle is A, and that's A. This is also A, and let's call this B and B. So as you can see, you got the same length, the same angles, and this AC, this line AC, that means that the line AC is indeed an axis of symmetry. It's divided the shape and it causes a reflection between the left and the right. So therefore, yes, the answer is yes. Which triangle is congruent to triangle ADC? ADC is this one here, ADC. So which triangle is congruent to that one? Well, it's a top triangle, which is ABC. There you go. Question 7. The pairs of triangles shown are congruent. Name the congruent triangles giving the vertices in matching order. Okay, so I'll start with the this triangle here. I will say this is a triangle RST. Now this is congruent to triangle. Now we start with the R. R has the angle with a dot, so the angle with a dot on this side is G, so we put G. And the next one is S, and that one is the angle with the cross, so we find the angle with the cross on this side, and that's an F, so we write G, F, and the last one must be H. So there's your answer there. Whoops. Alright. Now this one, you're not given the angles, you're given the sides. So we have to write an expression. So I can say, I'm going to write the first one, triangle. Actually, I'll put it down here. Triangle LMN is congruent to triangle. Now we start with the L. L is this vertex here. Now this vertex has an angle that's opposite this length, which has a one dash marking on it. So we look for the other one which has a 1 dash marking on it, and this should be this angle here. So this angle should be your Z. Okay, so this will be angle Z. Now the next one is your M. Okay, the next letter is M. M is the angle here, and that's opposite the 2 dash. So opposite the 2 dash is this angle here, which is a Y. So I can say that's Y, and obviously the last one is X. So there you go. Question 8. The pairs of triangles shown are congruent. Find the values of all pronumerals. Okay. So we know these are congruent triangles because it says so in the question. Now it says find the values of the pronumerals. So let's look at X. X degrees is equal to, now X is, the angle X is opposite the length 15. So let's look on the other side. Opposite length 15 is 97. So X is equal to 97. They're going to be the same. Okay. Next one, you got your, once you find out the second one, you can find the third one easy. So let's look at Y. Y degrees is opposite the length with 9 meters. So opposite the length of 9 meters is also here. You got, so that means this is also Y. Okay. So Y is equal to 37 degrees, and obviously Z is going to equal to the last angle, which is 97. Oh wait, not 97, sorry, that's already taken. 46. Question B. Okay, we need to find D and E. So let's see, D is opposite the angle 54, so opposite 54 is 13, so therefore D equals 13. And E is opposite the angle 39, opposite 39 in here is 10, so therefore E is 10. Done. Question 9. Actually, you don't have to do this question, skip that question. Moving on to the next page. Okay. Determine whether or not the quadrilaterals in each pair are similar. So to determine whether these two shapes are similar, they have to have the same ratios of the sides. So I can say 9 divided by 12, 9 divided by 12 is equal to 6 divided by 9. Now, are these the same? Well, let's test it. To see if they're the same or not, we can do cross multiply. That's the fastest way. Okay, so I can say 9 times 9 is equal to 6 times 12. 9 times 9 is 81. 6 times 12 is 72. So 81 is not equal to 72, so therefore this is not similar. So no. Now let's look at the next one. Let's compare. I can say 21 over 28. So 21 divided by 28. Oh, actually, I'll draw some arrows so you know what I'm doing. 21 divided by 28 should equal to 12 divided by 20. Now, let's see if they're the same. Let's simplify this and simplify this. Simplifying that one, I can, let me see, I can divide this by 3, divided by 7, sorry, and divided by 7. So I'll get 3 over 4 is equal, divide this one by 4, and this one by 4. So I can say that's equal to 3 over 5, isn't it? Did I do it right? 21 over 28 is equal to 12 over 20. Yeah, that's right. So as you can see here, they're not the same. Okay, you can do cross multiply and you can see that's going to be 12 is equal to 15, and that's not true. So therefore this is not similar. Question 11. Find the scale factor for these similar figures and then find the value of the pronumerals. Now the scale factor is how to get from this to this. We have to multiply by something, and that multiplication number is called the scale factor. It could be, maybe this shape has been, enlarged by a factor of 2. It might be double in size, or it might be triple in size. It might be 1.7, in size. Anyway, let's get rid of that. So we need to find the scale factor. So to do that, what I'm going to do is I'm going to get one of these units. So I'm going to compare, for example, 28 and 40. Or I can do 42 and 60, same thing, okay? But I'll do 28 and 40. So we know that 28, when you multiply by the scale factor, let's call the scale factor x, it's going to give you 40. So let's find out what the scale factor is. 28 times something is 40. So let's divide both sides by 28. Divided by 28, and you get x is equal to 40 over 28. Now we're going to simplify this. Divide top and bottom by 4, you're going to get 10 over 7. So therefore the scale factor is equal to 10 on 7. I'm just going to leave it like that, it's fine. Now I want to find the value of a. There's only one pronumeral here, that's a. Actually there is two. Okay, I'll do a first. Alright, so to find a, we know that 3.5 multiplied by the scale factor will give me a. So, sorry, not 3.5, that's 35 times a is equal to, sorry, not 35 times 10 over 7 is equal to a. Alright, let's process this. Now 35 is a whole number, so it's over 1. Now we can simplify. I can divide this by 7, I will get 1. Divide this by 7, I will get 5. So really, it's 5 over 1 times 10 over 1, which equals to 50 over 1, which is just 50. So a is equal to 50. There's a. You can do the same thing for b. Now we can say that 10.5 times, so this times by the scale factor, which is 10 over 7, will give me b. So that means 10.5 times b, sorry, times 10 over 7 is equal to b. Okay, so let's change this one to a fraction, 10.5 times it by 10 over 7. Change this one to from mixed numerals to improper, you're going to get 21 over 2 times it by 7, sorry, 10 over 7. Now I can simplify this. I can say this one can be divided by 7, that'll give me 1. This one divided by 7 will give me 3. This one divided by 2 will give me 1. This one divided by 2 will give me 5. So really you got 3 times 5, which is 15, over 1 times 1, which is 1. 15 over 1 is just 15. So therefore b is equal to 15. There's your answer for that one. Alright, next question. For each pair of similar triangles, show that all pairs are matching. Show all pairs of matching sides are in the same ratio and state the scale factor. Okay, so part 1. I'm gonna rub out some of this stuff is in the way. Okay, so let's find the matching pairs and so on. First, I'm gonna find out the angles, because that's the easiest way. So we don't know what the angles are, but I'm going to label them. So I'm going to label this one a circle with a hole in it. Okay, that's an open circle. So opposite, now this angle is opposite 33. Now 33 is the largest. Okay, the largest, and let's look at the second one. We know that these two triangles are similar. It's given to us. So let's look at this one. The second triangle with the largest length is 22. So that means opposite that one must also be the circle. Okay. Whoops. Now, let's say the smallest, the smallest length, the shortest length is 24. So this is the shortest. This is the largest, the smallest. Actually, I'm going to label this by small, medium, and large. Whoops, medium should be here, large should be here. And this one would be small, medium, and large. Okay, so opposite the largest is the angle P. That's that one there. We've done that. Now, opposite the small is angle. The smallest is, I'm going to label this as X, or just a cross. And opposite that one, so opposite this one must also be the X there. So there you go. Okay, and obviously the last one, I'm just going to put a dot, a closed circle. Alright, there you go. Now I can write the matching sides and the matching angles too. Find all pairs of matching sides and matching angle. But you know what? I'm going to do the last part first here. It says name the similar triangles given the vertices in matching order. So let's do that. So I'm going to do part 3 first, because it's going to help me with the other questions. So I'm going to say triangle OPQ is similar to triangle. Now what's the other one? We start with the O, which is the vertices with the angle that has a dot, and corresponding to that is corresponding to that is this one here that has a dot as well, and that has L. Next one is P. Now P is the angle with the open circle. The angle with open circle for the other triangle is N. And then obviously the last one is M. There we go. Now, I technically don't need any of this anymore. Okay. Actually, I'll just leave it there just for your understanding. But technically I don't really need it. This will be a circle there. And the reason I don't need it is because I have this now. Once I write the expression with the matching vertices, I can do the part 1 and part 2 very easily. So part 1 says state the scale factor. I can do that later. Show all pairs of matching sides. Okay, no problem. I can say, for example, OP. So OP is going to equal to LN. I can say PQ is going to equal to NM. And I can say, what else? I can say that I think OQ is going to equal to LM. Done. And you can test it out. You can see, look, OP is this one here equal to LN. LN is this one here, and you can see they're both the smallest length. See, so it's all good. It's all matching now. Now let's find out the scale factor. All right, so let's see. Oh, by the way, these are not equal. This just to mean it's matching. So I should put the triangle. They're not equal to each other. Okay, so let's look at the first one. OP, which is 24, is the same. Is the matching side would be LN, which is 16. Okay, what's the scale? What's the scale factor? So let's see. So 16 times by some unknown number. Let's call that X, and that should give us equal to 24. Okay, this has been expanded by some factor. So let's see. So to get X is equal to, we divide both sides by 16, and you're gonna get 24 divided by 16. Now let's simplify this. 24 divided by 16. The top will be, let's divide the top and bottom by 4. You're gonna get 6. No, actually divided by 8, you're gonna get 3 over 2. So the scale factor is 3 over 2, or you could, oh, that's just 1.5, isn't it? Okay, but I'm just gonna leave it as 3 over 2. So the scale factor is 3 over 2. There you go. Scale factor. Now it says find all pairs of matching angles. Okay, not a problem. So part 2, they want me to find all pairs of matching angles. I'm going to use this. let me just rub out this part here. I could say angle O is equal to angle L. See, angle O here equal to angle L. Angle P is equal to angle N. P is equal to N. And angle Q is equal to angle M, as you can see there. Okay, easy. So once you have this expression correctly written out, you can find out the matching sides and the matching angles very easily. That's why I did that first. Alright, you can do... Maybe I'll help you with this one here. I'll write the expression for you. So let's look at question B. Let's look at the shortest side. Where's the shortest side? The shortest side is this one. This is the smallest side. The longest side is this one here, and the medium size is this one here. Alright, let's look at the other one. The shortest side is 13.5, so that's the smallest side. The longest side is 21, and the medium size is 18. Alright, so let's label this triangle here. I'm going to put a cross, I'm going to put an open circle and a closed circle. Now, the open circle is opposite the longest side. So, open circle should be here because it's opposite the longest side for this one. Alright. Now, the shortest side is opposite the angle that has a dot. So the shortest side is angle with a dot, so it should be this one here. Okay, and obviously the last one is going to be the X there. Done. Now from here, I can write the expression. I'm going to write the expression up top here. I can say triangle CDE is not congruent, so similar to triangle. Now CDE. Alright, so C is the one with the X, so this one here must be Z. D is the angle with the open circle, so it must be this one, which is X. And obviously the last one is Y. Okay. So let me rub all this out. Alright. Now from here you can write all of the other stuff. So you can say, for example, matching sides. You can say, for example, CD is equal to ZX. You can say DE is, oh sorry, not equal, it should be matching, not equal, so just put an arrow there. So DE is equal, is gonna be matching with XY. And you can say CE is matching to ZY. Okay, those are the matching side. Now the matching angles. Matching angles, you can say angle C, angle D, and angle E. Angle C is equal to, will match with angle Z. Angle D will match with angle X, and angle E will match with angle Y. Done. And to find the scale factor, you just have to compare the lengths. Let's look at the, you can do any length. Let's look at this one. C and so angle Z, not this one, sorry. You can do, let's say this one here. CE and ZY. CE is 14, ZY is 21. So we look at 14. I'm going to write up here 14, and somehow it's going to equal 21. We know it's multiplied by some scale factor X, so let's divide both sides by 14. So that's going to give you X is equal to 21 over 14, which equals, let's simplify this, 21 over 14. We can divide them both by 7, and you're going to get 3 over 2. So the scale factor is 3 over 2. Done. Scale factor is equal to 3 on 2, or 1.5. Okay, there's all your answers there. Question 13. The triangles shown are similar. Name the similar triangles given the matching vertices in matching order. Okay, not a problem. Now, let's look at the shortest length. Would be this would be the shortest length. I'm going to call this the smallest length or the shortest length, the longest length, and the medium length. And on this side, we have the. Let me get rid of all this. The shortest length would be this one, the longest length, and the medium length. Now, the longest length is opposite 74. So, opposite length to that. So this one should equal to 74 as well, because that's the longest length there. So S is equal to 74. So this one is 74. What else? Okay. And what else we got? We got the shortest length is opposite 43. Shortest length, opposite 43. Shortest length, which is this one should be 43 as well. So you got T equals to 43. And obviously the last one, so I'm going to write 43 here. And this one obviously has to be 63. U is equal to 63. So to write the expression, we're going to go CED. So S is equal to 74. That would be your so that's equal to C as well. 43 is equal to your D, and U, and 63 is equal to E. So when we start with C, we have to say that's going to equal to S, because they're both equal to 74. And then the next letter is E, so that's going to be your U, and then the last one will be T. So CED equals to SUT. There you go. Find all the values of pronumerals. We did that already. We're done. Okay, question 14. Find the values of the pronumerals in each of the pairs of similar triangles. Okay, this is really easy. You can say, because they're written in a way where everything is matching, we can just do a simple comparison. We can say 3 to 9. Well, we multiplied that by 3, didn't we? So we multiply this by 3, we get K equals to 24. Easy. Now, the second one. Again, everything is matching, so I can say, well, from 35, I'm going to 30. Okay, I don't know what that is. So let's, instead of doing that way, we're going to do a different comparison. We're going to say 35 over 49. So 35 over 49, and that's going to equal to 30 over W. 30 over W. Now, before we continue, I want to simplify anything where I can, okay? So you look at this, and I see, can I simplify this? Okay, yes I can. I can divide them both by 7. 35 divided by 7 is 5, 49 divided by 7 is 7. And that's going to equal to 30 over W. Okay, now this one is simple. You can see that from 5 to 30, all I did was just multiply by 6. So therefore, I multiply this by 6, I'll get W. Or you can do cross multiply, up to you. So W is equal to 7 times 6 is 42. Done. Next one, question C. Let's have a look here. You got the angles a bit mixed up. Opposite the angle that is a dot is this one here. So so those two lengths, 12 and 16, they are matching sides. So I can say something like 12 over 16, and that's gonna equal to, let's say, this would be 21. That's the only length we have, so that's 21 for the top, and for the bottom it has to be, now 21 is opposite the angle with like that, so that one should be A. There we go. Now we just simplify. So let's look at this and simplify this one. So divide the top and bottom by 4, you're going to get 3 over 4 is equal to 21 over A. Now you can do a quick comparison and you can see that this is times it by 7. So this must also be times it by 7. Or you can do cross multiply. Okay, so you can say that A is equal to 4 times 7, which is 28. Or you can do cross multiply and get the same thing. Here's cross multiply. Oh, whoops. You can say 4 times 21 is equal to 3 times A, and then when you work it out, A is equal to 28. Same thing. Alright. Question D. I'll let you do that one by yourself. Next page. Alright, for each pair of similar triangles, copy the diagram, mark in the equal angles. Okay, so they want, and then redraw the triangles separately and in the same orientation and find the value of the pronumerals. Okay, what they want to do here is, we've got a triangle here, and they want to draw this triangle just like the one here in the same orientation. We know that these two triangles are similar because these two angles are similar. It's the same, sorry, they're the same. These two angles are the same because alternate angles, and these two angles, this one and this one, are the same because alternate angles. Okay, so what I'll do is I'll draw another triangle for you. And I'll just color that in. Then I'm going to flip this around. So now I'm going to take this triangle and make it look like the first triangle. So what if I was to do this, something like this? Okay, now alright, we can see here, oh whoops, I forgot to label the length. So this is 14. This one, this length here is 12, so this one must be 12, and the other one must be 16. Alright, done. Let's rub this out. So let's compare these two triangles. Now find the value of the pronumerals. The only pronumeral we have here is this length here. Oh, actually there's two. You got A and you got B. So let's compare the lengths. Okay, I can say for example 12 over 14 is going to equal to 15 over B. So 12 over 14 equals to 15 over B. Let's simplify this 12 over 14 here. Divided by 2, you're going to get 6 over 7. So we got 6 over 7 is equal to 15 over B. Do a bit of cross multiply, and you're going to get 6b equals to 7 times 15, which will give us, what is that? 7 times 15, 6 times 15, oh, it's 75, that's right. So b is equal to 75 divided by 6. And that's going to give you 12 is 72 to 12. And remainder 3 over 6, so it equals to 12.5. So the answer for B, so B is equal to 12.5. There you go. Now A. Let me just rub all this stuff out. Okay. Now I'm comparing it to this triangle here. So A is, I can say that, for example, A over 15 is equal to 16 over 12. Now let's simplify this. I can divide them top and bottom by 4. I'll get 4 over 3. So A over 15 is equal to 4 over 3. And you can see pretty clearly that to to get from 3 to 15, I just multiply by 5. So to get to 4 to A is multiply by 5. So A is equal to 4 times 5 equals 20. A equals 20. Done. Okay, next one. Now these okay, these are the same thing. You can do those by yourself. I'm going to do question 16 now. Alright, so question 16, I'm going to redraw this. Okay, so what you have is two triangles. That's the first, oh actually that's bad drawing there. Okay, that's the first triangle. Now second one is going to be something like this. Okay, I'll move it down so you can see. Right, so now we know the candle is 420 centimeters from the wall. So here's the candle. This is the wall. So this is 420 centimeters. And we know that this is the shadow, by the way. This is the shadow of the candle. And that is 40 centimeters. And we know this one is to be, this one here is 30. And these are two similar triangles. Oops, we don't know if they're 90 degrees or not. Don't worry about that. So that's 30. Now we need to find how far it is the ruler from the candle. So here's the ruler. And this is the candle. So we need to find x. I'm going to call that distance x. So we use similar triangles. So these angles are the same. These angles are the same, and these angles are the same. Alright, so I could say, for example, I can say x over 30 is equal to 420 over 40. Alright, let's simplify this. Let's divide it by 10. Now divided by 2, we get 21 over 2. So I have x over 30 is equal to 21 over 2. Now I just do quick cross multiply, and I can get 2x is equal to 21 times 30. So therefore we divide both sides by 2 to get to x. So x is equal to 21 times 30 divided by 2. Let's cross this out and cross this out. This will be 1, this will be 15. So really, x is equal to 21 times 15. Oof, that's a big number. Let's see what it is. 21 times 15. Whoops. Let's see what we get. 5 times 1 is 5. 5 times 2 is 10. Match equals 0. 21. And you're going to get 315. So therefore, the distance for x is 315 centimeters. And now is asking the ruler from the wall. So the ruler is around here. So this is, so from the candle to the ruler is 315 centimeters. So that's the distance there. And now, let me just rub this out here. The distance from the candle to the wall is 420. Now the question is, what is the distance from the ruler to the wall? Well, to find that, all you gotta do is take 420, take away 315, and that'll give you the answer in centimeters. Alright. Hope that helps.